I waited till that loaded because I actually took this picture. So it's my first time in Prague, first time in Brno, first time in Czech Republic. And I walked across the bridge today and took that picture. Just want to thank Kiwi for having me. I actually spent 3 days in Brno with the Kiwi team. I think the biggest thing that I learned was I was the one learning the most. I see you, I see Katya, all the data scientists at Kiwi. I think that the skill and talent there was actually amazing. And my job today is actually to teach you about how to make your life easier with data science and machine learning on Google itself. Quickly, my name is Mikhail Chrestkha. I'm a customer engineer. I support Google Cloud Platform. Who here has heard of Google Cloud Platform? About half the room, so hopefully at least I'll get that awareness up a little bit more for next time. I also actually worked for Ernst & Young Consulting as well as IBM for 6 years before my time at Google. So I have a little bit of experience now in the machine learning field, as well as what businesses are actually doing and are capable of actually in the business side of things as well. Quickly, I think when you think of Google, outside of Google Platform, you probably know our consumer products. You probably have heard of search, Gmail, YouTube. A lot of you probably use Chrome and Android for a lot of your mobile and web services. And each one of these now actually has over 1 billion users each. And it really, when Amazon, Microsoft, and IBM really led the revolution towards cloud computing, Google was secretly really doing this and driving the network infrastructure to actually power all these products. So we have these 7 products, and we had already built a supercomputer that was global to really empower all these things. So the one thing that I really want to stress around this is that Google does have the largest global cloud in the world. The green lines on the graph here are actually undersea cables that Google actually purchased and installed themselves. There might be other cloud providers that talk about that, but Google really does have one supercomputer that you can really think about that really drives global computing. Now in terms of Google Cloud Platform, for half of you who have not heard about us, outside of YouTube, search, Gmail and all that, there is a new organization called Google Cloud. Google Cloud also has a couple of other pieces. G Suite is really Gmail, Google Drive, Google Sheets that are offered to enterprises. Chrome, Android, Google Maps as well. The Google Cloud Platform is really focused on cloud computing, and I reside within the data analytics and machine learning team there. Outside of ML, we actually do allow you to host a lot of your web applications. You can use infrastructure, networking, storage, as well as build full applications as well. So hopefully half of the room now you know Google Cloud Platform. It's really one of the newer businesses. At my time at Google, I've actually felt like it's still been a startup, even though Google has been around for almost 20 years now. Quickly about Google Cloud Platform as well as the machine learning services. As you see in the very middle, Google Research has produced a lot of research papers around big data processing, 15+ years of solving big data problems to allow us to really allow you to use YouTube, Gmail effectively every single day with very, very little blackout periods. Now I don't know if it was a year or 2 ago, we actually did have a shutdown here in Czech Republic for a few hours or so. So I know that's the case, but now we're investing. It is billions of dollars of capital investment in our network to make it work. But really the idea here is that Google has already been a foundational origin of really delivering products to the open source community. So our GFS at the very right, MapReduce, that really evolved into the Hadoop ecosystem. We also ended up writing research that resulted in HBase, Drill, Crunch, most recently Apache Beam and Tensorflow. So you can really envision, when we talk about Google Cloud Platform, you can now think of that as a way to really harness Google's technology faster and quicker. If you look at MapReduce and GFS, it took almost 15 years for that to really be able to be absorbed by enterprises, developers, startups, etc. But now when you think of TensorFlow, TensorFlow was only developed in 2015 from a research paper perspective. We started using it about 2013, 2014. It's already been open sourced and released as a managed service within Google Cloud Platform. So Google Cloud Platform, moving forward, we hope that the time for you to have access to all the technology that drives all of other Google's products really is shortened moving forward. Quickly, why are we here? We're talking about machine learning. We have the services out there as a managed service, but the reason why we think we can help you is because Google isn't just really talking about machine learning, it's actually applying it. So all these products you see here, all the little text behind it, that's actually machine learning driving it. Even Google Search a couple of years ago wasn't leveraging machine learning as much as it should be, and now machine learning is the third largest signal that drives your Google search results. We have photos. If any of you who use Google Photos, you can actually now use vision object detection to actually search for cats, mountains, dogs, water, etc. Recommendations for YouTube and a lot of other things here. So really the key around Google is that while a lot of people I met in Brno, PhDs, they're really driving the research. We want to help that with TensorFlow, but our secondary objective is to make applied machine learning as accessible to businesses as possible, because we think that's really also a great objective and priority. Just a quick example before I get into our actual services. Diabetic retinopathy is actually an eye disease that half a billion people are at risk globally. And really, you're at risk for blindness. It's something that the medical community is very aware of, but it's very difficult to train. For everyone in the room, who thinks the left side is unhealthy? Just want to raise your hand. We got a little bit. Right side? You guys are pretty good. So the right side does detect hemorrhages. But the main point is Google researchers thought, hey, this is a problem that is affecting almost half a billion people around the world. We're at risk. We don't have enough medical education globally. How can we use machine learning to actually solve this using image recognition? And recently, again, with now the advancement of cloud computing, we were able to use deep neural nets to actually solve this problem. It's still undergoing development, but we really used over 150,000 images. We used a panel of doctors who actually had the pre-trained data set, and we were able to train it to actually perform at an average level. So it's not perfect yet, but it was able to outperform an average doctor. This is an example of why this is actually important. The y-axis is actually each image, and the x-axis is actually each doctor's graders. So even doctors who are trained and paid to do this, they can make mistakes. This green box right here, for example, they think that this person is healthy, but they're actually, if any other doctor trained it, that patient is actually under risk. So this is kind of the value you can really do, especially in third world countries across the globe where they don't have the education, they don't have the expertise. This is where machine learning really comes into play. This specifically, you see the logo of TensorFlow in the bottom right. This is where it can really make a difference in the unstructured image space. So now Google Cloud. How can Google Cloud Platform actually help? We have various different levels here. A lot of you have heard of TensorFlow at the very left. It's open source. It's really meant for the machine learning researcher. We think that if we open sourced it quicker, we get more people to adopt to it. We let academics who are best at it push it further. That's definitely one use case. But what I want to focus on is the next two. I think the right is actually, who here has never built a machine learning model? Great. So we have a little bit of it. So we understand that some businesses, some companies, they don't have the resources to hire data scientists, or I should say they're not there yet. They're not at the maturity level to actually have a data science team, but they want the power of data science. And that's really what the pre-built models of Google allows you to do. That's something that Google has built models specifically in the unstructured data space. We're talking 90% right now. Again, I think we mentioned Deloitte releasing a study. Other consulting companies have said that 90% of enterprise business data is unstructured, and machine learning has mostly been applied to the 10% that's been in your nice tabular format. But on the right side, all these services that I'll actually do a quick demo on as well is around speech to text It's about identifying objects from an image. And most recently, earlier this year, we actually released a video intelligence API to actually detect things in video. And on the middle here is really more around a managed service around Tensorflow. If you still want to build Tensorflow models, but you don't want to deal with having to buy 20 supercomputers, install Tensorflow on all of them, and allow for parallel computing, you can pay Google for 10 minutes of doing that, and it'll spit out the model for you. We're still working on that, but that's really where we want to make an investment in that middle layer. So I mentioned the pre-trained models. Cloud Translate API basically allows you to detect languages. It can translate to and from over 90 languages at this point. I think it might be 100 now. Speech API, just audio to text. Natural language API is around sentiment analysis. Was it good? Was it bad? How strongly does the text really do that? We have video vision and jobs API. But I want to jump into demos to really give you a feeling of what that actually looks like. I'll start with a quick video one. This is very, very new. From an object detection standpoint, that's been around for a while. But from a video detection standpoint, the previous method was really around splitting up the video into image frames and really detecting that. I know that the buffer with the internet, so I'm going to rewind real quick. But the one thing I want you to notice is on the right side, it actually gives you the objects it's detecting and the percentage, how confident is it about that. So animal, 72%, fox, 51%. As it goes through every single shot, it detects shot changes, it detects different entities, and it's giving you what do you think. So when you think about video annotation, companies like Netflix and Hulu and all Vimeo, everything you think of, they've been paying humans to watch those videos. NBA.com, NFL.com, they've been paying humans to do that. And this is something that we released recently. All you need to do is do a REST API, really input your video, and you get a JSON file that gives you all this information. Now that's the quick scenes there, but while you can look at it in real time, it actually takes less than the real time of the video to actually go through the entire video and really decode everything that's going on. So you can see basically, and next time you want to see when is nature there, when is mobile phone, you actually know the exact location and time it's there. And when this is again right now, the use case is specifically for the media and entertainment industry. We work with a lot of companies in Southern California and Hollywood to really help with the startup media space. But if you apply it again with that eye example in the healthcare field, there's a lot of different applications. Maybe traffic cameras that are detecting Amber Alerts because there's been a child stolen. Like we're working with a lot of government agencies around those things. So really, it is creativity that is the main barrier to this. In terms of Vision API, you can play with this actually on our website. Again, I told you I was exploring Prague today. I just basically placed an image of here. Our image API is getting better and better every single day. There's a couple of things here. Number one, it does detect landmarks. So I was here today, and I thought it was amazing. And now Google did actually detect exactly where it was and can apply it on the map. In terms of labels, this is probably the official pre-trained deep neural net model around image recognition, where we have pre-labeled training data sets. We actually do pay other companies and we get the pre-labeled data. So data is king in this example, but the labeled piece is where we want to really put a stamp of approval. If you want to use this data, we really think this is good data. So here are the percentages, landmarks, city, tourist attraction. If you want to use that to actually extract features from images. So you can use, even though this is machine learning, you can actually use it as an upstream process to feed downstream machine learning models. If you want to really use crowdsourcing, that might be a little bit less confident, but you can use the power of the web where you can also look at how does this relate to Google search images, and maybe you can get one level detail more. So in an example where Google's labels might give you plane, the web detection might give you Boeing 787-8. So things like that where you might want to do it's a little bit at risk of your own. You need to make sure you understand that there might be errors on there, but it's also a great thing to look at. So again, from a out-of-the-box APIs, for everyone who raised their hand here who has never built a machine learning model, those APIs are meant for you. We think that without any need for that type of experience, there are certain use cases where you can build apps that can really change certain industries. In this case, in the very first column on the left side here, this is where we think things like this can actually make an impact. You saw a video and image, but from a speech text perspective, customer sentiment in the customer service industry, we're talking about extracting text from images. Our Vision API actually also has what we call OCR, optical character recognition. So if it sees a license plate, a credit card number, a logo, a company name, a street name, it's going to pull that as actual information. Actually, the one thing I forgot to show quickly for the developers in the room, what does this actually look like? For you to play with all these things, when you give it a REST API call, it's a JSON output. With all these different features, everyone here who knows R, Python, you can basically use your data wrangling skills to extract those features with certain thresholds that you want. So that was for the folks who want to leverage the power of ML without necessarily that much knowledge, or for folks who are machine learning practitioners, data scientists, but they want to extract features from images and unstructured data without having to do it themselves and then run additional models downstream on the structured data. But again, Tensorflow is probably, that's been really exciting in the ML community. I'll spend 5 seconds on this. It's basically in the last year jumped to being the #1 machine learning framework. We're really overtaking all the other competitors combined. But really, there's a couple of things why that's actually happening. #1, it really is about distributed computing. Similar to MapReduce, Hadoop, all these big data findings that Google has made. Similarly, really the real bottleneck and barrier to machine learning has been parallel distribution computing. You can train these on CPUs, GPUs. I'll do a quick 5-second thing on TPUs later on. But besides training, machine learning, predicting things on any device is very important as well. If you've used the Google Translate app, if you use the Google Photos app, a lot of those machine learning models are actually very lightweight. You can download them on your phone offline. So that's really where the Tensorflow, it is a framework, it's a big community, but it's trying to make a true consistent standard for machine learning where you can really speed up the development of a machine learning powered application really, really quickly. TensorFlow layers. TensorFlow, while all those benefits that I just mentioned, is still very, very difficult. It has its distributed execution engine. That's really probably the power of it. It also has running on different hardware across mobile devices, big supercomputers, but that really makes it really hard for new people to adopt it. So in the very top left here, that's what we're trying to do to make it a lot easier to start building models. So we have Keras that I know a lot of folks that I met over the weekend that really was something that's been used. But there's also these canned estimators that are models out of the box. They allow you to really build models very quickly. I'll show you how the code looks like. But it allows you to really train, evaluate, predict, and deploy the model very quickly without much code. So again, those canned estimators might reduce your accuracy a little bit. If you actually want the full potential and you want to put in the effort to really get into the low-level code, you can absolutely code at this level. But if your use case doesn't need it and you want to get started with machine learning, you can start with the very high levels as well. Also, I think TensorFlow with the canned estimators, the light green at the very top. What does that exactly mean? I think TensorFlow, when it first started, we absolutely believe unstructured data is the focus, and we're focusing on neural networks. But I want to make sure everyone is aware that it's not just deep learning. We have classification techniques like SVMs, we have k-means clustering, we have time series models like ARIMA. Then we also have combinations of normal regression models, classification models, as well as actually combined ones as well. So this is just so you know, there are actually canned estimators for you to use. How do you use them? Don't look at the code. The only thing I want you to notice is that the left and right side are exactly the same code except for the box figure. And this is a regression model that probably even the folks who raised their hand who have never done machine learning before, you've probably built a small best fit line in a graph in Microsoft Excel or Google Sheets, and you've built a regression model before. And this is how you build a neural network using one of the canned estimators. It makes it a lot easier. Now this is a very simple example, so don't get completely carried away where you can build it from scratch, where this is just one feature or input to predict housing prices. But this at least gives you an understanding of how much easier the canned estimators make it. Now, there's two things around TensorFlow. I think algorithms and models get used very synonymously quite often. Number one, there are a lot of state-of-the-art algorithms. Those are, again, those canned estimators. You can build your own low-level models. We're talking about wide models, which might just be a regression model. We might talk about deep models, which are your deep neural networks. But the great thing around it is, let me go back 2 slides, we have these combined models. The third one and the sixth one, where we talk about DNN linear combined classifier, as well as combined regressor. Those are things where it is still an R&D space, but I have the Google Play example there because in the recommendation space, this was actually proven to have a better performance than a wide or neural net. And usually when you compare wide models versus deep models, you're really doing cost-benefit analysis on memorization and overfitting versus really generalization and making sure when you see new data, you're gonna hopefully get a good result. And these middle layers is really where I think TensorFlow also has a big advantage. So you can read the research paper around Google Play, and this is actually, again, similar to the code example I showed you previously. It really is just a canned estimator where you use one of these just quick codes. I talked about algorithms versus models. Algorithms, you build your own models. You have to have your own training. You have to really build it from scratch. What TensorFlow also offers, which I think a lot of people don't recognize, is actually pre-trained models in R&D space. They're not as easy to use as our APIs that I showed you, but from a research model perspective, there's things that you can actually access right away and also just leverage a lot of the power. I'll start left to right. At the very left here, it's actually an image captioning model that has been published for you to actually train yourself and see if you can evaluate yourself against a test image. But this, instead of just object recognition, instead of seeing a train or a person and a mountain, a person skiing down a slope, or a person on a beach flying a kite, the output was actually the caption of the image. On the bottom middle there, this is actually a little bit of the math. This is the concept of transfer learning, where if you are familiar with it, you can actually use this code to really leverage a lot of the power and the architecture, because deep learning is really more of an art than a science right now. And if someone has figured something out, like in the bottom middle there, that's really Google's inception model around image recognition. Maybe you can use 80% of it and train the last 20% for your specific use case. So if you're a company and Google's Vision API isn't good enough, but you don't have a data science team, but you know someone who's a data analyst / data scientist, they know how to run TensorFlow code. Maybe, hey, let's try to use Google's model and then just train the last piece of it on our images. So that's the use case there. And then here on the bottom right is just how many models there are. I know the image ones are very cool, but there's a lot of other ones in the speech space and the text space that you can really leverage. So really, just make sure you understand the difference between algorithm and model when you're using TensorFlow, because TensorFlow is now becoming a large community, not just a framework. So we talked about the very right side, so the pre-built models for app developers. All you need to know is maybe JavaScript, maybe Python, just quick REST APIs. TensorFlow on the very left side around the ML researcher. But we did open source TensorFlow, so you might say, okay, TensorFlow, why would I need Google then? You open source it. I can run it on my local machine, I can run it on another cloud provider. And number one, that's absolutely true. If that's absolutely your choice. I think one of the themes of Google Cloud is we don't want to lock you into our services. But the middle service is Cloud ML Engine. Even if you decide to use TensorFlow, there's still a lot of headache. You still have to create your cluster of servers. You have to install TensorFlow on all of them. You have to install all the drivers on every single one of them. You have to make sure that you can distributedly compute all your models on there. So Cloud ML Engine, what you can think of it is a managed service for TensorFlow. PaaS stands for Platform as a Service. So it is a platform as a service for TensorFlow. 100 workers means basically it can scale up to 100 servers at one time. Monitoring, logging, I think the main thing also is with deep learning applications, it's not the training that actually, training is absolutely the most compute heavy, but prediction is just as hard. It's not as simple as regression models where you can just hard code some simple coefficients and if-then statements for decision trees. We also have version management. And the great thing is, you can try it, you don't like it, move the TensorFlow model to a local server or into another cloud provider. So this is really where we think Cloud ML Engine is really our big bet around making it as easy as possible to run TensorFlow models for R&D as well as development. I mentioned I talked about TPUs. I actually don't know too much about them, but all I know is they're really fast. I know they're still very new. They were released within our I/O Summit earlier this year. So this is going to come soon. This is going to be pre-built into Cloud ML Engine. Right now it's still alpha. We're working with a couple of choice customers. But overall, I think the theme is I showed you the big map around Google networking and how we are creating a one global supercomputer. The reason we're able to do that is because we build our own custom software. It's not just hardware. We actually harden everything. We're I think a top 5 manufacturer at any given point for a lot of the different chips and motherboards that actually build our own things. And TPUs, or tensor processing units, it's something that came about where we thought, you know what, we want to build a piece of hardware that is optimized specifically for machine learning, because we believe now that we are from a web to mobile first world, we really think we're mobile first to AI first, and TPUs is really going to be a driver of that. So this is pretty much my last slide. The one thing I want you to take away is whether you're a PhD student who's doing research, whether you're a developer at a startup, whether you are part of a data science team of a big enterprise, we can meet you where you are. If you want to build your own model, we know the headaches that you have to do everything. You have to build your own hardware, you have to set up all the software, you have to make sure that you create a cluster of nodes if you need parallel computing. But if you just want Google help there, that's fine. That's a little bit outside of our machine learning services, but Google virtual machines, as well as the ability to run Spark ML jobs on Hadoop, we can meet you there. But where I really want to focus on are the last 3 columns. I talked about Google ML APIs. Again, this is for developers. You don't have to be a data scientist. I talked about Cloud MLE, where if you still want to build your own code, you like to get into the middle, you think that your expertise will generate the most accuracy for the models, that's where Cloud ML Engine is. I personally think that the absolute sweet spot to really gain value as fast as possible is the hybrid model around transfer learning, around our product team making the APIs a little bit more customizable, where you'll be able to train the images and videos yourself, but still keep it to a REST API call. So that's really where I think the sweet spot is, and really we want to make sure you understand the value of that. So that's all I have. I'll leave you with this kind of funny ML image. Basically, if you want to build a model around breakfast, food, or dog, this is almost disturbing. Yeah. So hopefully, for those who didn't know about Google Cloud Platform, you learned a little bit more. For those who knew about it but didn't know how it could be helpful from a machine learning standpoint, you learned about all the different ways across the spectrum, whether you're a researcher, a developer, or a data scientist. All right, I think I'll hand it off to the next session.